Okay, Bismillahirrahmanirrahim. So I've already asked you to plot your graph beforehand. This experiment is basically looking at how the temperature, capital T, oh no, I don't think I should have charged my Apple Pencil. Okay, so basically how the capital T, which is your temperature, and the lowercase t, which is time. So how changing the temperature can vary the time taken for the reaction to happen. Okay, so you have to manipulate the numbers a little bit. You have to log them, but basically the idea is the longer or the bigger the time in seconds, hold on, the shorter the time in second, the bigger 1 over t, and then log 1 over t will be a negative number. Okay, so that means it will be more negative, and the negative sign is just, you can just ignore the negative sign and just look at the magnitude as it is. Okay, hold on, it's not responding. Okay, and then you have to plot, and these are some of I managed to take some of your work. Okay, so I noticed that there are generally two types of plotting or two types of graph. This is the first one where you see that you can spot the anomaly, one on the left and one on the right to the line. Okay, just give me a few more minutes. I'm still charging my Apple Pencil. That's why I cannot point at things. Another one is this, where you can see that there are 2 points, 2 anomalies that lie on the right side of the line. Okay, so there's no right or wrong. It all depends on how you draw your straight line. Okay, and let's see. If you think about it, if you look at the expression, okay, log 1 over t is your x-axis, y-axis. 1 over t is your x-axis. Okay, so if you look at the expression in terms of y mx plus c, okay, let me try it again. This is y, this is y, m, x plus c. Okay, can you see that log 1 over t is your y-axis, 1 over capital T is your x-axis. Okay, your c is 0. So that tells you that the graph must pass through the origin. The y-intercept of this graph is 0. Okay, can you please check again if you did not do this? Let me check. But you will not be penalized if you don't make it go through 0, okay? But sometimes the expression can help you give an idea, okay? First of all, you know that it is a y mx plus c, so it must be a straight line, not a curve. And secondly, the fact that the c, the y-intercept, is 0 from this expression, then it has to pass through the origin, okay? But if you don't have your, if your line is not going through the origin, it's also fine, okay? You won't be penalized, but that's a hint. So what do I mean by this just now? Now the instruction asks you to circle actually the anomaly, okay? From this graph, okay, one of your graph, I've chosen one of yours. That looks like an anomaly to me. And that also looks like an anomaly, okay? So this is the first case or first scenario where you have anomalies to the left side of your line and to the right side of your line, okay? That's the first situation. The second situation is you have both of your anomalies on the right side of the line. Okay, right. So what's happening here is that I know the numbers may be confusing if you look at the graph, like 3.0, 3 times 10 to the power of minus 3, and then 3.6 times 10 to the power of 10 to the power of minus 3. Okay, so this is showing you an increase in temperature. Is that right? 1 over T. Your temperature should be increasing. Yeah. Okay. So 3.47. Yeah. Okay, let's have a look at the first question. Maybe I should cannot draw. Okay. On your graph, circle the 2 points you consider to be the most anomalous. Label each one with a different letter. Explain what may have caused each of the anomalies you have identified, giving a different reason each time. Okay. So you have to label them A and B. Okay. Make it clear in your answer to which point you are referring. Okay. So you have to label this. We'll start with this kind of graph. If your graph looks like this, where you have anomalies on each side of the line, okay, so you will follow this explanation. So I'm going to label this A and B. Okay, so I'm going to talk about A first. Now, if you notice that A lies on the left side of the line, okay, so if you have other points that may not necessarily be this exact point, but they lie on this side of the line, okay, the explanation will be the same, the reasoning will be the same. Okay, so what is this line saying? Basically, this point should have been down here, okay, according to your line, right? But you happen to plot it from this experiment. It's not your fault, it's this experiment. They happen to have a point that is higher. So that means the time is higher or longer than expected. Okay, so you need to give a reason. What are the possible reasons that can cause you or cause a person to think that the reaction takes longer than it is supposed to? Okay, that's how you see it. Line is here, but your point is here. So that means your point takes longer than the expected value. There. Okay, reasoning. One of the reason, let's look at the example again. A magnesium strip is added to the boiling tube, the mixture stirred, and the time taken for the magnesium to disappear. So you're taking the time taken for the magnesium to disappear. Okay, that's how you know the reaction has stopped or ended. Okay, so one reason that could cause this anomaly is that the time of disappearance of the magnesium, disappearance of Mg was thought to be later. Okay, now this is, you know, human error. Sometimes we may think that there's still magnesium there. I mean, very unlikely you still that there is magnesium still there, but actually the magnesium have long gone or long disappeared or long dissolved. So you continue to take the time still. Okay, another possible reason is, this one is more likely, the time stopped was too late. Again, human error. Maybe because the reaction was so fast, you didn't manage to stop the timer on the spot at the correct time. Okay. Okay. So that you can choose either one of this reason. Okay. Same thing. Oh, sorry. That since there are 2 points, you can choose one reason for each point. Okay. So to explain A, you can say the time of disappearance of magnesium was thought to be later, and then to explain B, the time stopped was to no, sorry. Time B would have a different explanation. Sorry. Okay. So that's for point A. If you have points to the left side of the line. Okay. Now we want to look at B, which is on the right side of the line. Okay. If you look at B, the point is here. Okay. But B technically should be somewhere here. Okay. So now we say the time taken for B is shorter than the actual one, or shorter than expected. So you need to explain what possible reasons can cause the time taken to be shorter than expected. Okay, so some of the accepted reason, of course, opposite to A, the time of disappearance of MG was thought to be earlier. Okay, so this is the more common reason. You may have thought, oh, my magnesium has completely dissolved, but actually there are still some magnesium there. Okay, so that means the reaction hasn't stopped, but you already stopped your timer early. Okay, that's why your point of B is earlier than expected, shorter than expected. Okay, that's the first reason. Second reason, same thing, it's the opposite to your reasoning for point A. The timer was stopped too early. Okay, or you just choose one. You only need one reason for one point. Okay, point A, choose one point, and then point B, choose another point. Are you okay? Right, so I'll leave it there. If you need to copy that down, you can always refer it back to the YouTube or take a screenshot of this now. Okay, next one is if you have a graph that looks like this. Okay, that means your anomalies, both of them, lie on the right side of the line. Okay, again, you also must label them as A and B. Maybe I'll use a different color. Okay, label them as A and B, but since they lie on the right side of the line, you just follow this argument. Right side of the line. Choose one for each point. Okay, these 2 points for the, if you have a graph that looks like this. Okay, that means you will say the magnesium may have been thought to disappear early, or you stopped timer too early. Okay, screenshot this now. Please make sure you understand which side of the line your anomaly is sitting on. Okay, if you have more than 2 anomalies, please choose 2 points that are furthest away from the line, right? In this case, I mean, this doesn't look like an anomaly because it's not so far from the line, but it's okay. They want you to just choose 2, so please take 2, okay? Right, moving on, determine the gradient of your graph, state the coordinates of both points, write down the coordinates, and record the value of the gradient to 3 significant figures. Okay, so I want you to do this, right? Follow the instruction, 3 significant figures, calculate the gradient, okay? After you find the gradient, use the mathematical relationship on page 5 to calculate the activation energy. Okay, so if you look at this expression, I've already explained this to you earlier on just now. Okay, your y-axis is the log 1 over t, so that's y. Your x-axis is 1 over t, so that means this whole expression is your gradient. Once you find the gradient, you can then equate gradient is equals to negative EA over 0.0191. So you know gradient, then you can find EA. Okay, you just have to play with the numbers. After you, so part D, 1 and 2, okay, you will do this later, right? Because otherwise we will not have enough time. I want to move on to part E, F, G, H first. Okay, so those are the ones that need explanation. State whether you consider the results to be reliable. Okay, reliability. Okay, so reliability can comment on your points. Do you feel like your points are close to the line or very far to the line? Okay, for me, for these two graphs, the points are close to the line. Okay, so this, I would say that the result is reliable. Okay, so where is it? Here. So you will say that the results are reliable because most points are close to the line. Okay, but if you think that they are not close to the line, that you maybe, I don't know, maybe in physics they teach you differently, like you may say, oh, those 2 points are actually far away from the line. You also can say that the results are not reliable, but your reasoning will be the opposite. Okay, not reliable because the points are far from the line, or most points are not on the line. That is also fine. Okay, this one looks like a good plot because you can see that these points are sitting exactly on the line. Yeah, and this one. So again, it all depends on your own perception of your graph. So they accept reliable with correct reasoning. They also accept unreliable with correct reasoning. Okay, if reliable, you would say that most points are close to the line, but if you want to say unreliable, you have to choose the opposite reasoning, which is most points are not on the line. Okay, student X commented that the data collected at higher temperatures in the experiment may be less accurate. Okay, so higher temperature means your reaction would be fast. Yes, reaction rate increases. Time also increases. No, time decreases. Sorry. Time decreases. Okay. So state whether student X is correct. No. At higher temperature, the time taken would be shorter. Oh yeah, correct. Yeah. Okay, so they're saying that this is less accurate Okay, now if you think about it, if your experiment runs for a short while, you have minimal heat loss, okay? So you have less heat loss, right? But that doesn't apply here because they want to talk about accuracy. For accuracy, we can talk about error. Okay, so let's talk about percentage error, where you have the smallest reading over the value times by 100. Okay, smallest reading, what's their smallest reading? Time is 1 second is the smallest reading. So that means the smallest value is 1 second. That means it's half of the smallest value. Okay, so error in the timer that this experiment is using is plus minus 0.5. Okay. Okay, now we go back to this error calculation. To find the percentage error, the formula is smallest error, the half of the smallest error, which is plus minus 0.5 over the value that you use, the time taken that you use, times by 100. Okay, so this is the formula of calculation of error. Now, if you look at your time, okay, I said time will decrease, right? So that means your value will be time, the value for time is small, right? And the value of time is on the denominator. That means if the bottom part of the fraction is small, the percentage error will increase. Okay, so we say that this student is correct. Is correct. Okay. Shorter time will result in a bigger percentage error. Okay, so if you are wondering where to find this formula, please refer to your paper 3 or this practical notes that I gave you like at the very start of your lower 6 last year. Okay, percentage error is the smallest error divided by the value. The value is the number that you are recording. Okay, if you're taking the time, that means it's the time. If you're taking the volume, it's the volume. So it all depends on your experiment or on your setup. Okay. Right. Of course, bigger percentage error means you have more error in your results, so your accuracy will go down. Okay. So that's a little bit tricky, this question. For 1 mark, that question is tricky. If the magnesium strip is not stirred, it floats to the surface of the hydrochloric acid. State how this will affect the reaction time and explain why. Okay, so you imagine your reaction and then you have your HCl and your magnesium is only on the top part. Okay, and then no stirring. The reason why we want to stir our reaction usually is to ensure that the temperature is uniform. Okay, everything is being the temperature is spread out uniformly, and also because you want to ensure that the whole magnesium is reacting, the whole magnesium strip is reacting. Okay, now the problem with not stirring this reaction and letting the magnesium float is, even from my drawing, you can see only some part of the magnesium is touching the HCl. Okay, the other parts of the magnesium is not touching the HCl, and this causes your reaction to be very slow. Okay, so state how this will affect the reaction time. Obviously, because not all the surface of the magnesium is being covered or submerged by HCl, the reaction time, not talking about the rate, the reaction time is longer. Okay, the reason is you can talk about some parts of the magnesium is not in contact with the acid. Some parts of the magnesium is not in contact with acid, or you can talk about the surface area. Less surface area for reaction. Okay, so as you know, surface area is one of the factors that affect the rate of reaction. So small surface area, slow reaction; bigger surface area, bigger reaction. Okay, if we don't talk about surface area, you can also talk about the point of contact. Okay, only the bottom part will have contact with HCl. The top part will just be exposed to the air. Okay. The experiment in A is repeated using dilute ethanoic acid instead of dilute hydrochloric acid. So you already know the difference between these two. Ethanoic acid is weak acid, hydrochloric acid is a strong acid. The concentration of both acids is equal. The same temperatures are used. So state the effect this change in acid will have on the initial rate value. So we're talking about rate here, okay? Give a reason for this. Now, they both have the same concentration. However, ethanoic acid, since it is a weak acid, it will have less hydrogen ions, even though the concentration is the same, okay? Because dissociation or ionization is only partially, okay, or partly. Hydrochloric acid, being a strong acid, will have more H plus. So obviously, the concentration of hydrogen ions is different, but the concentration of the acids are both the same. State this initial rate value. So the initial rate will be, so we're talking about ethanoic acid, will be slower in ethanoic acid because of less hydrogen ions present. In bracket, you can write down less ionization. Okay. Any questions?
No.
No questions? Okay. So if you don't have any questions, then we can end the session here. Sorry?
Part C, how do you know that the time is the factor that affect the anomalies?
Part C. Oh, this one. Because you look at the graph. Okay? Because on the y-axis is time. Okay, and time is on the y-axis, so that is the dependent variable. Okay, why don't we comment on temperature now? Temperature, we are the one who is controlling the temperature. Temperature is independent, so of course we cannot comment on the temperature. We are the one that choose. We are the one who that chooses the different different values of temperature. Okay, so you usually comment on the y-axis. Okay, this is similar to the previous paper. Do we have that? This one. They ask you to explain anomalies, right? So for example, same thing. This is from the previous paper. We always comment why that point is higher. So why is the volume higher than expected? We do not talk about the mass. Always talk about the y-axis, the dependent variable. Okay, if we want to talk about this point, then we comment why is this point having a lower volume than expected. Okay, so that's actually a good question. Why do we comment on the y-axis and not the x-axis? Always talk about the dependent variable. Okay, is that answering your question, Safina?
Yes.
Okay. Anyone else would like to ask questions? I know I may have gone really fast with some of these questions because I know you can always revisit them when I upload the video on YouTube later. Okay? You all good? Okay then. We have about 5 minutes left. And if you don't have any questions, then that is all for today. Okay. Assalamu alaikum and thank you everyone.